All right, so I'd like to close out this last part of the live lesson on modules by talking about an NPM module that's so unbelievably useful, and we'll use it all the time, that I actually kind of can't believe it's not part of the core Node distribution, and it's called async. Let me show you how it came to be and sort of why it's going to be interesting to us. So in previous examples, we've done some simple file operations to sort of load in and print out the contents of a file. And I've gone here and I've sort of written another version of that to sort of show you where we'll run into trouble. So I've got a function here called load file contents. You give it a path and then it'll call a callback in the end with either an error or the text contents of that file. It'll first call open on the file system module. It'll then call stat to make sure it is indeed a file. And if it is, then it'll call read on that and read in the first 10,000 bytes. If that succeeds, it'll close the file, and then finally it'll call toString on the callback, and it'll make sure the data gets returned to the user. So I've got a little test function here. I've got a little test file, and it just calls that load file contents with test.txt. And if we get an error, we print the error out. Otherwise, we print out the contents of the text file. Okay? So let's take a test.txt. We'll go as bloop like that. And now we should be able to say node fopen sample. There we go. And that prints out the contents of our file. Let's go back here to our function. Now, there's one small problem with it, and I don't know if you can kind of see it or if it's bugging you a lot, but this code is starting to indent quite a lot. I mean, I've already got 1, 2, 3, 4 levels of indentation here, and it's getting a little crazier. A lot of programmers, what they'll do when they program Node is only use 2-space indentation. I don't find the spacing of that very easy to read, so I tend to use 4-space indentation, and that just makes this problem even more exaggerated. You end up with so many levels of nesting that the code becomes a little challenging to read and can be a little sort of frustrating. And if you're trying to keep yourself limited to an editor maybe on 80 characters or something, it actually becomes downright impossible to write the code in that sort of space. So what some people did is they found some common patterns and they wrote a module called async, which I'll show you how to use now. So first thing we're going to want to do is we're going to want to install the async module using npm install. And that'll go to our remote server, get it, download it, and there we go. And now if we look in our node modules directory, we'll see indeed there is the async module there. So I'm going to come back to here and I'm going to also add in a module called async equals require like that. Now async has a basic pattern. We're going to use a function to execute these sort of asynchronous calls in a series, in a row, and we're going to execute one at a time, and async is going to help us do that more cleanly using a function called waterfall. Now waterfall takes an array of functions to execute, and then when it's done calling those functions, it then calls a function that you provided called like a results function or something. So you'll give it an array of things to do. So we give it an array, and let's say function, and then each of these functions is given a callback. And when you're done executing it, you call this callback. Then it'll take the results from that callback and call the next function in the sequence like that. If there's an error during any one of these, it skips executing the next functions and just goes straight to the results function and gives that the error. If you call the callback with any parameters, they're added to the next function in the waterfall. So for example, I do something and then I get a handle, a file handle. I can then say callback no because there was no error, and then I can say pass the handle to the next function in the stream. The next function then will get the handle as one of its parameters and also the callback we're supposed to call. And if I want to add, I can add as many parameters as I want, and they'll just be added to the list of parameters passed to the next function in the waterfall series. Again, when all is said and done, when all of the functions have executed or an error has happened, the waterfall jumps to the sort of results function, and there I can do whatever I want. So what I'm going to do is I'm going to use the waterfall here to try to make our load file contents function a little bit cleaner. So I'm going to say async.waterfall, and first I'm going to create a little file handle here called f, and we'll create an array, and the first function in this will get a callback, and the first function is going to call fopen. Okay, and I don't really need to do anything else with fopen once I get it. So I'm actually not going to write my own little function. I'm just going to use their callback. Now, if file open returns an error, async waterfall is just going to go straight to my results function when I'm done. If it doesn't produce an error, what it's going to do is it's going to call the next function in the series with that file handle. So let's go ahead and do that. So we'll produce the next one in the series, and it'll get the handle that fopen returned. So now I'm going to say f, this sort of variable I've declared here, is the handle we got. So now the next thing I want to do now that I have the file open is I want to call fstat on it to sort of make sure that it is indeed a file. So here I'm going to say fs.fstat, which takes a file handle like that, and it will either return an error or it will return null for an error and return stats. So again, I don't need to write my own little function here. I can actually just pass to the callback. If there's an error, it'll jump to the results function. If there isn't an error, it'll go to the next function in the series, which is function, this takes stats, and it'll be given a callback by waterfall as well. Now I can say if stats.isFile, like that. What are we going to do if there is a file? Okay, so we've actually executed all of this. So let's clean that up. So if there is a file, what we want to do is we want to create a buffer to hold the contents. We'll create a buffer of 10,000 bytes, and then I want to do a read. So we'll bring that read up here. Now, again, I don't need to create my own function here. I can actually just pass to the callback like that. Now you'll see here that the callback from fsRead takes two parameters, the number of bytes read and a buffer. So we'll have to be sure that when we create the next function in our series, it takes byte read, buffer, and then the callback that async passes us. You'll also see here that in an error situation, we'll want to say make callback make error not file can't read it. Great. So now that definitely calls the callback, not callback, CB. We'll definitely call the callback for this async waterfall function in all cases. And in the case where there's a success, we now have the number of bytes read and the buffer. So what we'll do now is we're done with all of that. So now we just need to close the file here, and then we need to pass back the data to the sort of resulting function. So we'll say fs.close f, and I'm actually going to write a function here just because I need to pass the data back. So I'm going to say if then we can ignore everything and just call back else we'll say callback with no error, and then we're going to say b.buffer dot toString UTF-8, and we need the bytes read, so 0 to bytes read, like that. And then that's all there's to it. So now we have to figure out how we did all this with the parentheses. So our waterfall, that's the last function in our series. That's the array. Oops, I'm missing a parenthesis, bracket. Let's fix you. Nope, I need to there. And now you, and then I close my array like there. And now we need to write that results function, which is function results. And for some reason, my Emacs always puts that in a weird place. And then that's the and that's the end of the waterfall function. So we can actually just call our callback, this function. In the results function, we don't really need to do anything with the results. So if there's an error, we'll just call the callback directly with either the error or the results. So the load file contents will still load test.txt, and it'll give it a callback function which, given the error or the contents, will print them out. But you see here now our load file contents function, because of the async waterfall, is much cleaner. We've broken it up into little chunks, and instead of having these horrible nested chains of sort of nested callback functions, we've been able to describe everything in a very linear format. We're first going to open the file, and then we're going to give it the waterfall callback. If there's an error, it's immediately going to jump here. If there isn't, it's going to jump to the next sequence and pass the parameter from the handle parameter. Then we'll save that, and then we're going to get the stats of that. Again, if there's an error, it'll jump to the end. Otherwise, it'll just go to this function, and the stats will be the parameter passed. If there's a file, we'll do a read. If there's no file, then we'll just go straight to the end and call an error. And then we'll take the bytes that were read, the buffer, we'll close the file, and then if everything worked, we'll pass the string contents of that buffer back to the calling function here. So, assuming we typed that all in correctly, what are the odds we actually did that? I'm going to guess we typed something wrong. Hey, we did it actually right first try. Wonderful. Okay, so that actually worked great, and that is the basic introduction to async. That is the async waterfall, and it's probably the one I use the most just because it makes my code much easier and much cleaner. But async is in fact significantly more powerful than this and has a ton of stuff available to us. So I'll show you here the sort of async page in GitHub. A lot of these NPM modules are available on GitHub too. And you can see here they've got very good documentation for it. So I do encourage you to come back here and sort of look through it and sort of look at some of the examples and everything, because you'll see that all sorts of scenarios can be taken care of, and it'll help you out with a ton of different problems. Our code here has one rather serious problem that I'd like to fix right now, and that is, you see here, we can only read a 10,000 byte file, and if we get a file that's bigger than that, well, we're out of luck or something. So what I've actually done here is I've created a file called test2.txt, which is 20K. And I'm going to modify this to loop and keep doing reads until we've read in all the contents. Now, if you remember previously when we looked at some node patterns, we talked about using an iterator function and some recursion like this. We would do function iterator, and we would take an index, and then we would call it like that, and we would do some iterations over that. And that's all fine and geeky and nerdy and everything, and it's cool to use recursion and everything, but it is a little space consuming, and it can be confusing for some people who maybe aren't super familiar with recursion. So fortunately, async comes to the rescue again here with a function called async.whilst, and it's sort of an asynchronous version of the while loop. And the whilst function in async takes 3 parameters. The first is a test function that says, should I continue? The second is the async function to call, and it's given a callback, and you want to do your work here, and then at the end you must be sure to call the callback with either an error or no error. And then the final function is sort of a function to call when everything is all said and done and good and everything. So, results. Much like the waterfall, we have this sort of results function, and that's the sort of 3 parameters that the whilst function is given. So let's rewrite our read code to be able to loop through until there is no more stuff to read, and at the same time use the async whilst. So we are still going to use this buffer because we still need someplace to put the stuff we're reading, and then we're also going to say var bytes read equals -1. So our test case is going to say the read function will keep reading bytes, and it'll keep returning the number of bytes that it read until there are no more, and then it'll return 0. So our test function is going to be return bytes read not equals 0. If it's 0, then we want to stop reading, or stop looping. If it's not 0, we want to keep going. Okay? So now we're going to actually write the meat of our code, and that is going to be the read. We'll keep reading from the file descriptor into buffer from 0 to 10,000 bytes. We're actually going to write our own callback now. So we'll say function bytes read buffer. The read function gives us that. Okay, so, and an error, of course. So if there's an error, then we're done. Return. If there is no error, then we want to say bytes read. So we want to say bytes read equals BR, and then we want to say if BR is greater than 0, we also want to say var results equals, like that. Now we want to say results plus equals b.toString UTF-8 0 bytes read, like that. And actually, we don't need these brackets. And now finally, we can call the callback null. So, and then that is the end of our sort of workhorse function. So the good news is we don't need this guy anymore. But actually, we still want to have a close function, so I'll get back to that in a second. Okay, so we have our test function. We say as long as we're reading bytes, keep executing the loop. So we're going to read, and now we're going to say if we'll save these bytes read so we know whether to continue the loop. If we did get some bytes back, we'll convert what we got back to a string and sort of add it to the end of our, let's instead of results call it content. Results content. Like that, just because we use the word results elsewhere, and I think it might be confusing. So we'll call it the file contents, and then we add whatever we get to the file contents, and then whenever we're done here, we have the error in the results, and we can actually just say cb or results like that, and that's how we use the async whilst. Now we have some code here that's just going to keep looping and doing the fread until the fread returns 0 to say stop doing our work. So now when we're done, we actually don't need byte reads or contents anymore. We actually, byte reads or buffer, we just have actually the file contents, because this callback function here from the results will pass in the contents. Oopsie, good thing we caught that. Contents like that. That'll pass it back to the calling function, and if there's no error, this guy will get that. Now we'll close this out, and then contents like that. So that's how we replace a loop, a sort of while loop here using async. And it's a little less wonky, I think, than the sort of recursive iteration method and everything. So let's hope we typed all that one in, and let's change it so that instead of using test.txt, we use the much nicer and longer test2.txt. And boom! Totally did not do that right. So let's go to line 39, and indeed, it's content, not contents. There we go. And now we print out our nice long story and everything. And even if I wanted to, we could test it with the simple test.txt as well. And you'll see it works just perfectly fine. So that's another function that the async module provides for us. And there's actually a bunch more. So let's go ahead and take a look at a few of those right now. The waterfall function is a way to do things in series. You do one asynchronous function at a time. There is actually another function to do things in parallel called, well, async parallel. And again, it takes a function, an array of functions, and it either takes an array of functions, or one of the things you'll see that you can do is you can actually pass in objects instead. And what it does is it iterates on the member variables on the objects and executes those instead. So for example, let's say we have an object, and we will have some database operations that we want to do. So we can do function callback, and we'll say db query select star from users where user ID equals, something like that. And then when it's done, it'll say cb null db results. And then we also, at the same time, since we don't have to, we don't need to do them together, we can say file operations, and then here we can say function cb, and then this one can be file get contents user user ID like that plus profile pic.jpg, something like that. And then we can cb null file results. And then finally we can also do memcache, tag memcache. And then that can also be a function that, memcache d get tag cloud, for the user ID or something like that. And again, null cache results. So these functions will all execute in parallel, and now the cool thing is that object, we're done with this object. So now our results function that all of our async code will have, if there is an error, we print error like that or whatever, And else, what we'll get actually here is we'll get an object, and this object will have one member for each of the members that was passed in here to the parallel function. So the object would have database, DB results, and then it would have file, and then file results, and then it would also have tag memcache, memcache results like that. And so that's a way you can execute. See, where's my? There it is. And so that's a way you can execute stuff in parallel using async. And if you don't care about the order and you just need to do a lot of stuff at once, that's pretty cool and pretty powerful. There is an even cooler and more powerful function called async.auto, which lets you combine the best of the serial execution and the parallel execution. And like the parallel, it's going to take an array of things to execute and then call the results callback. So let's sort of take the code we have here from the parallel, and then we still have the same functions to execute on the member variables. We have the database, the file, and the tag memcache. Now, let's say in this example, we want the database and the file to execute in parallel, but the memcache, we have a situation where it cannot do its work until these two guys have finished doing their work. Well, the auto is really cool in that instead of providing a function, we can alternately provide an array. And the first things in the array will be a list of people that needs to complete their work before this one can do its work. So here what we've done is we've said memcache cannot do anything until database and file have done their thing. These guys can execute completely independently and nobody cares. To help us out, we are also given sort of current results so far to our function here for this dependent case in the auto. And what it'll have is it'll have a member called database with the results from this, and it'll have a member called file with the results from this function. And then we can use that to do our work. And then when we call the final callback here, then we'll go to the results callback. So that's sort of a really, really powerful way to combine the waterfall and the parallel functionality. That's something we use quite a lot too, as in addition to the waterfall. So it's definitely something to pay attention to. All right, so one other thing I'd like to look at is a for each loop. And again, we've seen like I want to iterate over 10 elements. I can do something called for each series. And what this does is it takes 3 parameters. It takes an array to iterate over. It takes an asynchronous function with the item at the current index, and then you do your work. And then again, you must call callback with an either error or results. And then finally, like all the other ones, it takes a results function or results. And that's how the for each series. If you don't need these to execute one at a time and you want them to just all execute as soon as possible, you can get rid of series and it'll just fire off all of the item iterator functions. If you need for sure to iterate over every element in the array, you don't need the series. If you're iterating over elements until you get some result and then you want to stop and you don't need to do it anymore, then you can use the for each series and you can use that to stop your work. So that's kind of a core introduction to the async module, and it's again something we're going to be using all the time, especially when we're doing a lot of asynchronous calls like talking to the database and working with file systems and everything. It just makes our life a lot easier and cleans up our code a lot, and like we just use it everywhere all the time. So I do recommend you sort of getting familiar with it and taking some time to get comfortable with it. And with that, we're done with lesson 5 on modules, and in our next lesson, we'll start looking at sort of expanding our photo sharing application and adding some cool new functionality.